So for this video today, we're going to be talking about light probes and how they can be used to light up our non-static objects using lights that are not real-time lights. So from my previous videos, we showed how we can use real-time lights, first of all. Second of all, we can use bake lighting for static objects for certain light sources that are not real-time lights. And in this scene, which I was using for some of my other videos, you can see the only light source we have right now is an emission light, which is not a real-time light. So we have this cylinder that has a red material which has an emission. It's emitting a red light. And we can see that reflected on our plane. And our plane is static right now. So if we go to our plane, we can see it's marked static. I had gone to lighting and I clicked generate lighting. And if any of this is not known to you, you can look at my previous two videos that I go over all about baked lighting and how to calculate that for static objects. But the question is what if we have an object that's not static? So I have a sphere here and it is not marked static. And it's not marked static because it is going to move. So static means that is an object that's never going to move in your game. Such as my mountain rocks here are static, and we can see that the red light is shining on those. And my plane is static. But in this case, this is going to represent a character that's in my game, and of course if it's moving, it's not static. And so we can see if we move this by our light source, it is not reflecting any color onto our sphere. So in this case, we want to have this light source affect our non-static object. Now if we turn on a spotlight, I'll just turn that guy on. So this spotlight is a real-time light, meaning real-time, meaning it is going to affect any object real-time as the scene changes. And it's going to light up everything frame by frame, which we can see as our sphere moves under the spotlight. We can see that spotlight is affecting our sphere. So let's turn that guy off again. So what we can do is, the problem is here is that lighting is expensive, as I mentioned before, meaning it takes a lot of processing power and computation to calculate how a light source that doesn't have a point source. Point sources are easy because everything's emanating from the same point. We can calculate a simple vector interaction with one of our objects and calculate that light fairly quickly. But in this case, and it happens to be a fairly regular object, a cylinder, but it can be any shape we want that could be emitting light. And so what we use in this case is a light probe. So if you think of it, how do we know how to light up this sphere from when we could have 4 or 5 or any number of light sources that are complex in this area? How are we going to calculate how it's going to light up this object? That is really the problem. And light probes help us do that by calculating, you could imagine every single point in space around the light probe about what all the light sources, how much light are they giving that particular point, and from what direction. I don't know if that's exactly how they work. That's how I would do it if I was programming it. So what we do is we can come in here, we can go to light and add a light probe group. And it is a group because it takes more than one light probe in order to do all these calculations. I assume they have to triangulate or do some amount of math in order to figure out exactly what points are for every single light in the area. So if we go to our scale tool, we can scale it just like any other object. Scale it some this way, a little bit more. to form kind of a cube around our area that we want to calculate the light from. Let's see how we are vertical wise. Go down a little more. All right. Let's scale it a bit vertically. All right. Adjust that up a bit. Okay, right about there. All right. So now we have our light probe group. So now what we're going to do is we are going to run the bake lighting light generation again, normally, which is what we use for bake lighting. And in this case, it's going to take all these light probes, do some calculation, and create extra information on how to light up a non-static object within their light probe area. And I don't know how it calculates it, but let's find out. All right, so if we select our sphere, actually I set up our camera to go to game mode, we can see that we now see some lighting on our sphere. And if we want to see how accurate it is, we can kind of move it. It's not bad. You would expect it to be lit up right in this face and only this face, but it's kind of lighting up more on this side than this side. So it's giving us some light, but it's not really that accurate. So in order to increase the accuracy, what we have to do is we have to increase the number of light probes. So we increase the number of points where it's calculating all that light information. And so what they allow us to do is if I have this light probe selected, we can go to this little edit tool, and what it allows us to do is edit the light probes. So what I can do is I can add a probe. So I'm going to add one, and I'm going to move it kind of right in between our cylinder and our sphere. Let's add another probe, and what I'm going to do is I'm going to add a probe kind of here. Then, oops. Add a probe on the other side. So now we have extra light probes in order to hopefully better compute the amount of light that's going to be shining on our object. And now what we see is we get a much better accurate representation. It's lighting up the sphere when it's right in front of it. And now when we come over here, it's lighting up kind of this side of the sphere. And as we move away, let's see where he is. It's lighting up kind of this side of the sphere. You can see it kind of goes through a pretty big transition change from here to here. But what you can see is that it depends on how much accuracy you want. I assume the more light probes you do, maybe the more data it has to store. And so there's always going to be a balance between the amount of data you want to add to your game and the better lighting accuracy you're going to want on your characters or non-static items as they move around your scene. So this is the basic light probe. So the other light probe is called a reflective light probe. So let's look at that next. So when looking at lighting in the real world, remember the light that you see an object as, or the color you see as an object as, is the light waves that are reflecting off of that object to give it that color. So in the case of our plane here, the plane looks red because all of the light emitting from the cylinder is bouncing off the plane and back to our eyes. That's what it's really simulating. So it's not direct lighting that we're seeing, but it's actually light that's bouncing off of the object. Now that light that bounces off the object not only goes to our eyes, but could also hit another object and then bounce off that object and come to our eyes. So again, you can imagine that adds another layer of complexity when calculating light that's bouncing around our scene. And you can imagine multiple light sources bouncing off of multiple objects. And that's what really gives, if you're looking for a really realistic look for a game, that's what makes it look more realistic. Sometimes you look at a scene, you're like, this just doesn't look quite right or real. And the reason is because of the complex way that light actually is used in the real world and how it interacts with objects. So in order to calculate that light that's reflected off of another object onto our object, what we need to do is we need to add a reflection probe. And so when we do this, we don't get the little probe points. What we just get is a volume, a rectangular volume, that is going to represent our reflection probe area. So it's going to calculate the reflection values all within this sphere. So let's move it kind of this way. Let's check from the top. Okay, that looks pretty good. Check from the side. All right. So now what we're going to do is we are going to generate our lighting again, and it'll use this reflection probe. And now we're going to grab our sphere and let's slide it in. And what we can see is as soon as it passed within our reflection probe area, and this material that I made has a very high smoothness, and it's a metallic material, so it's going to reflect more than another one. And so we get this reflection. It's not perfect there, and if we select our reflection probe, we can kind of see this represents the calculation it used for our reflection. If we move this up a bit, what we can see is we can see more of this light kind of here as our reflection, because he was like right on the surface before, so we didn't see anything on the bottom of him. Could try to adjust this to see if that makes a difference. Kind of did. Again, it's hard to say exactly what the math is working at. In that position, in this position, it's looking pretty realistic. Again, none of these are going to be perfect. They are all estimations. Doing full real-time lighting just takes a lot of work. And I assume if you had more than one reflection probe, and the more other light probes that you add, the better your lighting computation is going to be. But again, that's going to add overhead onto your game. So like in all lighting, you have to decide how realistic do you need it? What is the look you're going for? But all these are tools that you can use to help light up your scene, which can really add a great effect onto games, give atmosphere, have dark areas that you can't quite see what's coming at you. So I hope these helped. You understand lighting better. Again, it takes a lot of kind of trial and error to see what works best in your scene. So I look forward to another video trying to figure out what to look at next. And I hope you enjoyed this. Thanks for watching. Bye.